Alright, I finally had the Predicta holiday all back together. If you recall, after I got it working initially, I removed the main circuit board to replace some bad tube sockets, and while I had it out, I encapsulated my replica K-networks in epoxy and painted them. I also coated the flyback with some RTV 133 silicone. I removed some rust from the chassis. I replaced all the resistors on the IF board, and I tinkered around with the power switch. I still have the original in here, and it seems to be working okay. I did find somebody who has some new old stock replacements that should be here in a few days. For now, though, I'll just go with that switch. I'd also talked about trying to use a motor run capacitor in place of those huge filament dropping resistors down below, but before I mess around with that, I want to make sure it's still working as is. So I've got it all plugged in and ready to go, and let's see if the switch will work this time. Yes? Alright. So this is with the original number 44 bulb. And something else I was tinkering with was using a white LED. Well, that's a good sign. It's an even better sign. Alright. After all that tinkering, I didn't break anything. It's very good. This is a fairly weak, low power analog broadcast. And I don't have much of an antenna hooked up, so just the fact that I can get this in is a really good sign. Because when I initially powered this up, I tried to pick up this channel, and I wasn't able to. I got sound, but no video. So perhaps changing these resistors in the IF have improved the gain. Because some of those resistors set the bias on the tubes, which sets the gain. Right now my antenna is just like a 3-foot long piece of wire. Alright, so I'm going to tinker around with that white LED and the motor run cap, and I want to move on to some other issues. I've temporarily hooked in the motor run capacitor so I can see how it'll work out. Remember, the goal is to replace these 3 power resistors that kick out quite a bit of heat. One end goes over to the thermistor and the other end goes over to the first tube in the series string, this guy. So these are the 3 resistors we're going to be replacing. And as for the thermistor, right now I've got a CL90 in there. Nothing wrong with it, works fine. But I found one that I think will work even better. This has a cold resistance of around 120 ohms and a hot resistance of around 3 or 4 ohms. Whereas this guy has a cold resistance of 265. And I'd say it's around the room temperature in my workshop right now, about 70 degrees. So that's even better than what they stated, which was 220. And the hot resistance should be about the same, or maybe a little bit lower than the CL90. I'll just bring my soldering iron close to it and you can see how the resistance really starts dropping. And when this is hooked up to power and you've got 0.6 amps running through it, it heats up quite a bit more even. Got down to about 27 ohms or so. It'll go even lower once it's actually got current running through it. Alright, so I'm going to disconnect that and wire that in. Now I don't want to risk burning out the CRT filament when I do this, so I'm going to go back to using my substitute CRT and plug this in. And at first I'm just going to watch for the tube glow. I got a pretty good idea of how bright a tube filament should be. Then I'll hook in an actual ammeter and see how much current it's really drawing. Okay, the new thermistor is installed. I've got my dummy CRT filament here, so good to go. I'm going to turn the lights off so we can see the filaments glow, hopefully. Turning it on now. No puff of smoke, that's a good sign. The tubes are starting to light up nice and slow, which is exactly what I want. If I got my math right, they're not going to get much brighter than this. The set seems to be running just fine, but I'd like to know how much current is really flowing through these tubes. So I've disconnected one end of the motor run cap and hooked in my multimeter in amperage mode. Got the red lead plugged into the 10 amp jack. Put this into AC mode here. Now I want to check two things. One is the startup surge current when the tube filaments are cold, and then I want to check the steady state current after the set's warmed up. I'm hoping that the surge current won't be excessive and that the steady state current is 0.6 amps or a little less. I don't want those tubes running too hot. So here goes. We topped out at 0.87 amps. Doesn't seem too bad. Be a heck of a lot higher if it wasn't for that thermistor limiting the startup current. Alright, the set's springing to life and we're right there at 0.60 amps. Better yet, we just dropped down a little under 0.59. Alright, cool. I'd say this is a success. So now what I'm going to do is remove those power resistors, and hopefully I can use them in another project so I don't waste my money on them, and see if I can mount this cap securely somewhere. It's got one mounting lug on here for a screw. If I can find a hole somewhere or create a new one, I should be able to secure that pretty well to the chassis. There'll be plenty of room under there with those resistors out of the way. I've disconnected the power switch yet again so I can try out this new old stock replacement. And now I can see why I was a bit confused when I first pulled it out. When I had dissected the switch to see what might be wrong with it, I pried off these top three metal tabs. But perhaps that's not what I should have done, because if you see the replacement doesn't attach here, it attaches with these four down here, which is the second tier. So that's the part here that actually encases one of the potentiometers. So when I take this apart this time, I'm going to pry up these four metal tabs right in the center. And then try popping this guy on. It sure looks the same to me, other than this being brownish and this being black. Otherwise, they appear to be identical. I didn't see any easy way to pry the tabs out of the center section, so once again I pried these tabs out and did the same on the replacement switch and have that mounted in here. So this metal collar is actually the new one, which I'm not going to be using, has retained the old one. So these tabs have been bent back and forth a few times now, so I really don't think they could handle one more round of this before they start breaking off from metal fatigue. But seems to be okay right now. And most importantly, seems to work fairly well. Now I noticed something kind of interesting while working on this, that there's a resistor in here between these two outer terminals. This is the contrast potentiometer. And as you see, they got a 1.5 mega cross there. If you look on the schematic, you don't see any resistor there. It's just a 1 meg control. Well, I lifted up one end of that resistor and measured the resistance cross potentiometer, and it was like 2.5 meg. You put that parallel with 1.5 or so, and you get a roughly 1 meg across there. So I'm not quite sure. This is an original Philco pot. Perhaps this was a later replacement and somebody didn't have the right value pot, so they just threw a resistor in parallel here. Maybe it was done at the factory. I'm not quite sure. It does make me wonder, though, if I had the correct control, would the contrast work a little bit better? Don't know. Seems to work okay as it is, though, so I'm just going to go with it. I removed those 3 power resistors and then hunted around for a space to mount this cap. At first I thought about this hole right here, but if I do that, it extends down a bit farther than I'd like. That might scrape on the bottom of the cabinet. So I looked for another spot further up, and I found this area here, but there wasn't actually a hole here. There were 2 holes in the bottom plate, but the top plate was solid. So I just drilled a hole there and tapped it. And now I can mount this down in there. There should be plenty of clearance. And then I just have to route a couple wires over to it. The one's right here. This one's too short, so I'm going to trace back to see where it leads. And I think it goes down in here somewhere. I think I'll just run a new length of wire up in there. I've got power switch, contrast control all rewired and mounted back in, and finally I wired in the AC LED replacement bulb. There's 2 wires coming down here. One's just going to the chassis, because remember there's a hot chassis set, and the other side goes to this point here, which is right after the power switch. So it's a little bit more work to get that cap wired in, and then we can try powering this set up with that LED in there and see what it looks like. I ran a new wire from the capacitor down, around, and around, and around, so it goes over to here, the horizontal output tube, and I put some heat shrink tubing over these terminals to prevent them from shorting out against anything. And one last thing I did was I remembered a suggestion from a few segments ago, which was to relocate the line filter cap from being right on the line all the time, which it was down here, and relocated it over here so it's after the power switch, which is this lead right here. Alright, so I'm going to flip this down and hook it up to a video source, and let's see how it plays now. Alright, here we go. LEDs are working just fine. You know, I kind of like this better in a way compared to the incandescent lamp, because it is so directional. It's just shining straight through the channel dial, which is what it's supposed to do. It's not supposed to be illuminating the surrounding area. It's just supposed to be a backlight. I'm just going with the over-the-air signal there, so got the good old local traffic report. So that seems to be working just fine, aside from some annoying hum. Well, I think I can take care of that. There's actually, I think what's called a buzz control, literally, on the circuit board here, and I've found with some fiddling that that's actually pretty key to the audio quality. So, let's see. it's not getting rid of the buzz. It might be coming through from somewhere else. Well, maybe an alignment will take care of that. Otherwise, that seems to be playing just fine. Now, before I move on to the alignment, I want to tackle this screen and clear off my workbench too, because it's a mess right now. So, as I was saying earlier, there's some bands on there. I'm going to take this plate off, get the band off, and get this cover off. And I'll start cleaning it up, but I think I'll save that for the next segment. That's kind of curious. The LED backlight, there must be a capacitor, or rather the LED here must have a capacitor inside. So there it's on. Turn it off, and it stays on for quite a while. It's surprising because the thing's so small, how big of a capacitor could be inside there. On the other hand, I know LEDs are pretty efficient, but I wouldn't think it would stay illuminated for 10, 15, 20 seconds after power is removed.